All right, so yeah, so the goal now is to, so we're gonna study different ways to measure the spread or the variation of the data, the spread of the data or data values. All right, so first we're gonna start with the range. So first, so one, the range. Okay. So what's the range? The range is, it's very simple. It's just the difference between the largest and the smallest data values, right? So the range, it's actually equal to the largest data value minus the smallest data value. Okay. It's just the difference between the largest and the smallest data value. So for example, like in the first data set, so the range of the first data set. So when I say the first data set, of course, I mean the five numbers here, right? This is my first data set. So as you can see in this data set or data values, the smallest number is 1 and the largest number is 39, right? So then the difference, so then the range would be 39 minus 1. So it's 39 minus 1. So then the answer is 38. Okay. Now, the range of the second data set. So it's just 22 minus 4. Sorry, 22 minus 18. So that would be 4, right? The second data set, as you can see, largest number is 22 and the smallest number is 18. So the range, so then the range of the second data set is 22 minus 18, and that will be 4. Okay, so as you can see, the range of the second data set is smaller than the range of the first. Okay, so in some sense, the second data set is more, let's say, more constant, right? And your first data set is more dispersed, right? So the range of the second is less. Range of the second data set, second data is less. Okay, it's equal to 4. So it's less than, of course, the range of the first. Okay. So what we can conclude here is that, you know, in some sense, so that the second data set is more constant, is more so what I mean by more constant, guys, here, I mean like the numbers, again, the numbers are kind of, you know, kind of close to each other, right? Like, again, like here, as you can see, I mean, 18, 19, 20, 21, 22, they are, you know, they are, the difference between like 18 and 19 is just 1, right? So, etc. So, so numbers here are kind of very close to each other. So they are, so that's why the second data set is more constant, right? Because the numbers are close to each other. And so now the first data set, so the first data set is actually more, it's more dispersed. Okay, because again, because, well, the range of the second data set is less, but then again, because as you can see, I mean, going from from 1 to 38, that's I mean, there are a lot of numbers between 1 and 39, right? So that's like a big jump compared to going from 18 to 22, right? So that's the idea. Okay, so you can use the range to compare the spread or the variation of two data sets, right? So if the range of, so like in this example, as we said, so the range of the second data set is less than the range of the first. So then you can say, or we can conclude that the second data set is more constant, less dispersed than the first data set. Okay. Does this make sense to you guys? This idea of the range and which data set is more constant or more dispersed?
Yes.
Okay, perfect. All right, now, so we can use the range. Now, next, we can use, and this is the big, I guess, one of the main tool we use to measure the spread of data. So two, we have, so variance and standard deviation. So I'm gonna go really step by step here, variance and standard deviation, because the formula we use to compute the variance and standard deviation is it's not easy. All right, so I'm gonna try to go step by steps. So first, I will use an example, show you how to compute this variance and standard deviation with my example, and then we'll have more examples to use the variance and standard deviation to to compare like two data sets. Okay, so first we're gonna learn how to compute this variance and standard deviation, right? And then after that, we're gonna learn how to use it to compare like the two different data sets. So let me go in with an example. Oops. So yeah, so the idea is that, so the variance, so this variance and standard deviation. Okay, so they give like a measure of so they give a measure of the deviation of data, measure of the deviation of the data from the expected value, which is the mean. So the expected value, it's actually the mean. So when I say here deviation of data from the expected value, again, the idea is when you have like data values, you have numbers. When you pick a random number, then the expected value, the value or the number you expect is always the mean. That's the mean. That's supposed to be the mean. So the mean is like, that's what you expect when you pick a random number, okay? But then you pick a number, and of course that number would be, in most cases, different from the mean, right? So you want to measure, the difference between the mean and the number you picked, right? The random number you picked, right? So the difference is actually, to measure the difference, we can use this variance and the standard deviation. So the variance and standard deviation tells you, they measure the difference or this deviation of the data from the mean. Okay. I mean, that's like the idea here. Okay. Now, well, before the example, let me just say, so if if the spread, so the idea is, so if the spread of the data of the data around the mean is small, if the spread of the data around the mean is small, then your standard deviation is going to be small. Then the standard deviation is going to be a small number. Then the standard deviation is going to be small. Okay. So for example, again, I'm gonna just use my example. If you take like this second data set, you know, we have this 18, 19, 20, 21, 22, right? And we said that the mean here in this case, the mean is 20. Okay, so what I'm saying here, guys, is as you can see, the variation or the spread of the data here around the mean is 20. 20, that's the mean, that's the average, right? And as you can see, the data values, they are not really far from the mean, right? They are kind of very close to the mean, okay? So the spread of the data here around the mean is small because the numbers, the data values, as you can see, the 18, 19, 21, 22, they are very close to 20, okay? They are very close to the mean, the 20, all right? So in this case, when you compute your standard deviation or your variance, then it's gonna be a very small number. Okay, so like in this case, so what we expect is, so when we compute the standard deviation, then standard deviation is gonna be small. Okay, so in this case, or in this example, the standard deviation is gonna be small, is a small number, going to be a very small number. Okay, and again, the reason is the numbers are very close to the mean. If you pick a random number, for example, I pick 21. Okay, I just pick 21. Okay, 21 is very close to 20, right? So what we are saying is, if you pick a random number, then if your standard deviation is small, it means that your number is going to be kind of very close to the mean. Okay, so any random data values. So in general, so your data values, they're going to be close. They're close to the mean in this case. Okay. Now, so this is when the spread of data around the mean is small. So now, if the spread of data around the mean is large, then you expect your standard deviation to be large, okay? So this is 1, 2. So if the spread of the data around the mean is large, then the standard deviation is going to be large. Then the standard deviation is large. Okay, and an example, I'm gonna use my first data set. All right, so in this first data set, we have like 1, 2, and then we have this 20, and then we have like 38, yeah, and then 39, right? So in this example, the mean, again, the mean is supposed to be 20, right? If you take the sum of all numbers, divide by 5, then the mean would be 20. Now, as you can see, if you pick a random number, for example, I pick, I don't know, just a random number. So let's say you pick 39, right? Well, 39 is kind of far from 20, right? I mean, the difference between 39 and 20 is like a kind of large, right? It's like, I don't know, 19, right? So what we are saying here is that the difference between the mean and your data value in general, okay, is kind of high or large, right? So the difference, so in this example, the difference between the mean between X bar and the data values is actually, it's large in general, it's big, right? In general. Of course, you can pick the 20. I mean, you can pick the 20 and 20 would be exactly your, that's exactly your mean, right? But in general, so that's what I mean by in general. And so if you pick another number, you know, the 1, 2, or 38 or 39, then they're going to be very different from the mean, right? So in general. So in this example, of course, the standard deviation is going to be large, right? So the standard, so in this example, the standard deviation is large. Okay. So that's, again, that's the idea, right? So now I'm going to show you how to compute the standard deviation and the variance, and then I'll show you how to use them to compare data sets. So now I'm going to answer following questions. So how do we compute the variance and the standard deviation? All right, so I'm going to take a numerical example. So I'm going to take and with the example, I'm going to, of course, give you the formula. I'm going to give you some definitions at the same time. All right. So I'm gonna we're gonna consider the following data. So let's say we have, again, five numbers. So let's say we have like 17, 19, 20, right? 27, and again, 27. Okay. So I want to discuss the formula to compute the variance and the standard deviation. So first, so in the formula we have like X. So step one, first, step one. So in the first step, what we do is we compute the sum of, so we're gonna compute the sum of X squared. So sum of X squared, this is, so it's denoted by so summation symbol, guys, don't forget summation symbol. This is a capital sigma, right? My capital sigma. All right, so the means sum, so sum of X squared. Now, what do I mean by X, right? So X, again, represent the data value. So X So the numbers, so we have the numbers 17, 19, 20, 27, 27, right? So X is just your data value. So what we do is we take, for example, so I want to compute the sum of X squared, right? So what I'm going to do, I'm going to take the square of 17, okay, plus the square of 19, plus the square of 20, plus the square of 27, okay, plus the square of 27.
So it's always square then, right?
Yeah, always square, yes. Okay, yeah, always square. And the idea here, I'm going to explain later. I mean, the formula, you see in the formula, we're taking the square because in some sense, we're applying like sort of like a Pythagorean theorem. I mean, we use the square to measure like the distance between your data value and the mean. But anyway, yeah, so it's always the square, okay? So that's the first step, right? So like in this case, 17 square, again, square means, so 17 square, that's like 17 times 17, right? 17 times 17, 2 times, right? So like 17 times 17, that would be, I think, 289 plus, again, so the 17 square, because this is like a common mistake. So it's not 17 times 2. It's really 17 times 17. Okay, that's what I mean by the square. Right, then 19 square, that's like 19 times 19, right? So that's 361.
So Professor, the square means 1?
No, square means you multiply the number by itself.
Oh, okay, okay.
So like 17 square, as I said, it would be like 17 times 17. 19 square, that'll be 19 times 19, etc. So like 20 square, that's 20 times 20, and that'll be 400. 27 square, that's 27 times 27, and that's, I think, 729. And again, 27 squared, so that's 729. So then this is the total. What's the total? It's 2,508. Okay, this is the sum of the squares of my data values. All right. That's the first step. Okay, we are not done yet. So the first step, second step. So we need to follow these steps all the time. Whenever you want to compute like a variance or standard deviation, this is like the steps you need to follow. All right. So we have the sum of X squared. Then step number 2, we're gonna need the square of the sum of the x's. So step 2, we need to compute the square. Compute the square of the sum of the x's of the data values. So this is denoted. This is denoted by. So we're gonna take the sum of the x's, the sum of the data values, and then I'm gonna apply the square. All right, so what I'm gonna do in this step number 2. So first, I'm gonna take the sum of the x's. First, I'm gonna take the sum of the x's. So I'm gonna take 17 plus 19 plus 20, plus 27 plus 27. Right? So this would be equal to, where is it? 88. Wait. No, sorry. Where is it? Yeah, 108, right? No, 110, sorry. This is equal to 110. Okay. So we're gonna just take the sum of the data values, but then you need to take the square of this sum. So we're gonna take the square of this 110. So 110 square. Okay, so you take the answer of the sum is 110, right? And then you take its square. So its square is, so 110 square, that will be equal to, where is it? Oh yeah, 12,000 actually, and 100. Okay, there's a difference, as you can see, there's a difference between first and the second step. It's not the same thing. I mean, it looks like it's the same, but it's not. In the first, you take the square of each number and then take the sum. The second step, you take the sum and then you take the square. Okay, I know it's confusing, but it is what it is. You know, it's so that's a step number 2. Well, we are almost done. Okay.
Hold on, Professor, real quick.
Yes.
So 1,
Yeah.
you do square and sum. 2, you do sum and square.
Yep.
All right.
Yep. Sum and squares. All right, so almost done. So in the step 3, so what we do is we're gonna divide this square of the sum by the size of the sample, by the size of the sample. So size of the sample, that's the number of data values, right? So how many numbers do we have, right? So that's the size of the sample. So we have 5 numbers, right? So we need to divide by 5, right? Because I have 5 numbers, 5 data values. So the size of the sample, that's the number of data values, right? And actually, it's denoted by lowercase n, right? And so in our case, in our example, it's 5. So what we need to do is, so we divide our answer in the step 2. So our answer in the step 2 was the 1200 and 100. So 1200. So the 1200 and one, sorry, so 12,100 over 5. So this would be equal to 2,420. Okay. Now, last step. So once you divide this, your answer from the step 2 by the number of data values, and the last step, we're going to take the difference with the first step. So step 4. Was a question for me, or probably not. So step 4, we're going to take the difference. Take the difference between, so step 1 and step 3, I mean, between the answers, of course. Take the difference between the answers. In step 1 and step 3, and divide by, actually, we're going to divide by n minus 1, by the size of the sample minus 1, by n minus 1. So in this example, in the first step, we got, oops. So in the first step, we got the answer was, the first step, the answer was 2,508, right? That's the answer from the first step, 2,500. Okay, and so this is the answer from the first step, step 1, right? Minus the answer from the step 2. Step 3. So step 3, we got, as you can see, the answer was 2,420, right? So this is step 3. This is 2,420 over, and then we said we divide by the n minus 1. So n, again, that's the size of the sample. We have 5 numbers, but we need to subtract 1, right? So we need to divide by actually 5 minus 1. So that's 4. All right, so here we divide by 4. So then the answer would be, so 20, let me see. So 2,500, 8 minus 2,420. The difference is 88. So that's 88 in the top, and then divide by 4. So that will be equal to, of course, 22. Okay. So this 22, this is your variance. So 22. So the variance is actually equal to this. So the variance is denoted by, I mean, it's just a notation, but it's denoted by S square. So this is S squared. This is just a notation, okay, for the variance. So the variance in this problem is 22. So the variance is equal to 22. So again, the formula I applied here, guys, is the following. So what I'm saying here, well, before the formula, so this is the variance. Let's just finish first with the standard deviation, and I will write down again the formulas. So for the last step, so this is the variance. Now the standard deviation is just the square root of the variance. So this last step, step 5. Step 5, the standard deviation, which is denoted by S. Okay, so variance is S squared, standard deviation is denoted by S, and the standard deviation is just the square root of the variance. So this is equal to square root of the variance. Okay. So like in our example, the variance was 22, right? This is the variance. So then standard deviation is just square root of 22. And so standard deviation is square root of 22. And if you compute square root of 22, then the answer, let's see, it's actually 4.69. So this is your standard deviation in this example. This is your standard deviation. So let me just write down here the formula I used, right, for the variance and the standard deviation. So what we are saying here is the following. So the formulas are the following. So for the variance, the S square, right? So the formula I try to explain here with this the 4 steps, you know, to get the variance. So the formula is actually the sum. So the formula is you have the sum of your x squared, the sum of the squares of the data values, minus, so we took the square of the sum, we divided by n, and then we divide the whole thing by n minus 1. So this is the formula we applied to find the variance. Now for the standard deviation, it's just, so again here, the n is the n, that's the size of the sample. Size of the sample. And the x is just your data values. Data values. And so then the standard deviation would be, and then the standard deviation, I'm gonna just use the red here for standard deviation. So standard deviation is just the square root of, as I said, of the variance. Once you find the variance, then just you take the square root. So S, that's square root of the variance. Okay. So again, guys, I know the formula seems kind of complicated, right? But all you have to do is just follow those steps, right? So first, there's the sum of the square, right? To take the squares of the number of data values and then take the sum. Then step 2, that will be the square of the sum. Then divide your answer in step 2 by the size of the sample. And then the last step, take the difference between step 1, step 3, and you divide by this n minus 1. Okay.
And you always remove one of the sample on
Yes.
step 4.
Yes. Yes.
Okay.
You always remove.
One.
Yes. Yes.
Okay.
When in the last step, this step 4, you always remove one from your size of the sample. Yes, always. All right. So let's do an exercise or example here. So
Professor, let me ask you a question real quick. Where's
Yes.
that 4? Because I was good with everything until we got to step 4. I know we did, step 1 and step 3 minus. And then now we're dividing by 4?
Divide by 4 because we always subtract. You subtract 1 from the size of the sample. You have 5 numbers, right? So in this step 4, you divide by your size of the sample minus 1. So you need to subtract 1 from the size of the sample. You have 5 numbers.
It says, so step 4, minus 1 from the size of the sample.
Yes. Minus
then
1. Yeah. Okay, so you take difference between the first step and step 3, and you divide by the size of the sample minus 1.
Okay. Divide by the size of the sample, you said?
Yes, minus 1. Yeah.
So you're gonna do the minus after, so I'm gonna do.
No, the minus. I mean, you see what I did here. You see when I divided. So when you take the difference and then you divide, so you divide by. You don't divide by 5. We divide by 4, which is 5 minus 1. Right here, I divide by 4.
Okay.
I mean, you don't divide and then subtract 1. You first subtract 1 from this from the size of the sample, and then and then you divide.
Okay. Oh, so after I get my total number, then when I go do the division, I subtract 1 from the data value.
Yes. Yeah.
All right.
All right, guys. So let's do an example exercise here. So, and at the same time, I'm going to show you how to use this standard deviation to compare data sets, right? So, exercise. So let's say we have random samples of the flowers diameters in inches. So we have a random two random samples of flowers diameters in inches. Okay, so the unit is inches. All right, so we have like two hybrids. There's a hybrid A. Okay, so the first hybrid A, the diameter is like, so the first flower, so we have like 6 flowers in this hybrid A. So we have 2, 3 inches. The fourth flower, its diameter is 8 inches, then 10 inches, and then 10 inches. Okay, and then we have another hybrid, hybrid B. Okay, and the diameters are like 5, 5, 5. Next, fourth flower, the diameter is 6 inches, 7 inches, and 8 inches. Right? So, well, let me ask you guys first. So of course, the question here is we're gonna compute the standard deviation of the hybrid A and then the standard deviation of the hybrid B. Okay. Now, so what do you think? I mean, what will be your guess? Is the standard deviation of hybrid A, is it larger or less than the standard deviation of hybrid B? Which one has the higher standard deviation?
B.
So,
oh no, is it A? Because it has 10 and
A.
10?
Actually A, because A, you see A, the diameters are more dispersed, right, than the B. So
Yeah.
which means the standard deviation of A is going to be higher, larger than the standard deviation of the hybrid B. So remember, we said if your data values are are dispersed, then your standard deviation is going to be kind of large. Okay, if your data values are kind of constant, then your standard deviation is going to be small. Okay, and as you can see, the hybrid A, the diameters the diameters are more dispersed than the B. Okay, so the guess here would be to say, well, our guess would be, well, the standard deviation of A would be higher than the standard deviation, or larger than the standard deviation of B. Okay, makes sense to you guys? So let me just write down what I said. So our guess here, what we expectation here. So hybrid A, I mean diameters in hybrid A are more dispersed right than hybrid B. Okay. I mean, as you can see from the numbers, right? I mean, like hybrid B, like you have like 3 flowers with the same diameter, and then next flowers is like 6, 7, 8, which is kind of close to 5, right? But then like in hybrid A, well, you go like from 2, and then you have like a 10 as diameter, right? So there's like a big jump here from 2 to 10 compared to 5 to 8, right? So yeah, so the hybrid A is more dispersed than hybrid B. So what we expect is, we expect that the standard deviation, so we expect that the standard deviation of A, of hybrid A, I mean, is larger or higher than standard deviation of B, hybrid B. Okay. All right. So if this makes sense to you guys, then so please, well, let's try to compute the. So question, please try to compute the standard deviation of hybrid A and so standard deviation of hybrid A and hybrid B. Standard deviation of so hybrids A and B. All right, guys. I mean, I'm going to give you some time to compute the standard deviation of the two hybrids. So please try to follow the steps. You know, the steps we have here. You know, I mean, I don't know if you're taking notes, guys, but yeah. Anyway. I'm gonna just remind you the steps, okay? I'm just right down here. So we said step one. So take the square and then the sum of the squares. Okay. Step two, you take the sum first of the data values. Step two, you take the sum of the data values, sum, and then square the answer. Take the square of the answer. Okay. Three, you need to divide your answer in step two by the size of the sample. Divide answer step two by size of the sample, so by n. 4. So in 4 you get the variance, which is the, so in 4 that's the variance, and to get the variance, so you take your answer from step 1 minus your answer in step 3, and then you divide by n minus 1. Again, n, that's the size of the sample. So this is your variance. This is your S square. And then step 5, the standard deviation is the square root of the variance. Standard deviation, square root of the variance. Let me just, I mean, if you want to check your answer. So the answers here, guys, and I'm probably gonna go over, I mean, one of the standard deviations. But the answers here for hybrid A, the standard deviation S should be equal to, I think, let me see my notes. It's square root of 14, so it's a 3 point, so standard deviation S should be equal to 3.74 inches. Oh yeah, by the way, guys, I forgot to say this, but your standard deviation, I mean, has a same unit as your data values, right? Like here, you have the flowers diameters in inches, so the unit is inches, right? So the standard deviation has the same unit as your data values, right? So we have so standard deviation here, it's 3.74 inches. For the hybrid B, your answer should be S should be 1 point, as expected, so 1.26 inches. So, I mean, as you can see, as expected, the standard deviation of hybrid A is larger than the standard deviation of hybrid B, right? So,
I have a question, Professor.
yes, please. Yeah.
So for my first step, I got 286.
96. Let me see my notes. Yeah, I think first step one, right?
Yep, and now I'm on step 2, and
Okay.
I just have like
Far so
4
good.
plus, I have
Yeah.
4 plus 9 plus 9 plus 64 plus 100 plus 100, and now I just want
Oh,
to like,
No, step two, we said it's you take the sum first, right? So
oh, the
2 plus,
286.
so I mean that will be the 2 plus 3 plus 3 plus 8 plus 10 plus 10.
Yes, that's 286, right? Because that was my sum for one, right?
No, I mean 2 plus 3 plus 3, that'll be 8 plus 8, that'll be 16.
Oh, because I'm
36.
adding the, oh, okay. So don't add the squared in. Because I was doing it squared. I was doing the answer that I got from the square.
No. So, I mean, you use the same answer as the steps. You are using your answer in step one. I don't like. Actually, I don't quite understand.
I'm getting confused. It's a lot of numbers. So I'm just gonna do for step 2, 2 plus
Okay,
3 plus
okay.
3.
I mean, like a step one, you take the square. So like you I'll just write it down here. So you take the square of the first number, like it's like 2 square, right? Plus, and then like 3 square, right? Plus 3 square, plus 8 square, plus 10 square, plus 10 square. All right, that's how you got, I guess, so this is like 4, 2 times 2, plus 3 times 3, that's 9, another 9, 8 times 8, that's 64, 10 times 10, that's 100, and there's another 100, right? So the total here, of course, that will be 286. Thank you. Now, step 2, you take the sum of the data values first. Like you take the 2 plus 3 plus 8 plus 10 plus 8 plus 10, sorry, which is 36, and then you take the square of the 36, not the square of 286.
Oh, so I'm adding
Mm-hmm.
And then
So-
I put that one number, well, everything that I added, then that one number, you said what, it was 36?
Yeah,
So then I take 30, okay.
the square of 36. So like step 2 would be like 2 plus 3 plus 3 plus 8 plus 10 plus 10. So like here, so the number would be 36.
Mhm.
But then I need to take the square of the 36. So then you take 36 square. Okay. And 36 square, let's see my notes. 6 square.
72.
Yes, you're right. So that's, yeah, 1296.
Wait, what? How'd you wait? Hold on. I thought,
36 times 36, right?
yeah, oh, okay, okay.
It's 36 times 36.
Oh, yeah, it is that big, okay.
Yeah.
All right.
And then step 3, we are supposed to divide our answer in step 2 by the size of the sample. So we have like, so we have 6 flowers. So we are supposed to divide the 1296 by 6. So this is step 3. And here we divide step 2, the answer in step 2 by the size of the sample. Right? Yeah, so that's what I said here. As you can see in step 3, we divide the answer step 2 by n, by the size of the sample. So we need to divide this 12, we have 6 flowers. So we need to divide this 1296 by 6. And so the answer is 216. And so 1296 over 6, we have 6 flowers. In hybrid A. So yeah, so then the answer is 216. Did anyone get the answer for the standard deviation of the first hybrid, the 3.74? Just to check if my answer is correct.
I got the same number.
You got the same number? Okay, good. Thank you. All right, that's cool. So then, yeah, so then in step 4, we're supposed to take the difference between step 1 and step 3. So difference, so step 1, the answer step 1 minus the answer in step 3. And then, as I said, divide by not 6, we need to subtract 1 from 6. So it's 6 minus 1, so we are supposed to divide by 5. Right, so that's step 1. We got 286. Step 3, we got 216. So we divide by 5. So that will be your variance. That's your variance. So the variance s squared. So the 286 minus 216, that's 70. All right, so 70 over 5. So 70 over 5, of course, that will be equal to 14.
Wait, so you just did 70 divided by 5, right?
Mm-hmm. Yep.
And that's how you got the 14.
Yeah, that's how I got the 14. And that's your variance. Now, standard deviation is just the square root of this answer. So the step, step
You know
5.
what I thought too? You know how you're saying N is the size of the sample, right?
Yep.
I thought that sigma thing was, you know, the thing that looks like a Z?
No,
I
no,
thought
it's
that was the,
No, sigma. That's a
Mhm.
summation. That's like the symbol for summation. This is like sum.
okay, I need to write it down. Okay.
Mhm.
Okay. Start.
So yeah, so step 5, you so standard deviation is would be the square root of standard deviation is square root of the variance.
1, 16.
So it's the square root of 14, which is 3.74 inches.
54 minus
And how'd you get the 3.74?
You take the square root. So yeah, that's actually a good point. Do you know, guys, how to? I mean, do you have a trouble with the square root? Do you know how to use the square root in your calculator? I mean, you need to find like the function square root in your calculator, right? So the function square root would be like the symbol is like this, I guess.
of course.
So what you're supposed to do is you're supposed to you're supposed to press like a square root, and then you're supposed to enter your number, and then press the answer. Yeah,
I got the, I have an X and then that square root thing.
Mm-hmm.
And then I have, no, it's an X and a 2. And then I have another X and then the square root thing.
Oh, there's like something like this.
Yeah.
Okay,
Yep.
that's fine. That's fine. That's fine.
So what do I put in? I put 3.74 square root.
No. You put first you put the square root, and then you enter 14. But the answer is the 3.74.
Yeah, I got it.
Perfect. Janine, you're saying the answer for yes. The answer for number 2 is 1.26. Yes. Does anyone have trouble with the square root?
And we get the square root from the from the variance. We
Yes.
have to do okay.
Yeah, the square root from the variance. Yeah. So yeah, so the answer for the hybrid B, as I said, the answer should be, I mean, of course, if I'm not mistaken, but then here I think Janine, she got the same answer as me. So so the answer for the hybrid B should be 1.26 inches. So the hybrid, so this is for hybrid A. So hybrid A. We are saying standard deviation is S is 3.74 inches. Okay, and the hybrid B, we are saying so the standard deviation should be 1.26 inches. Okay, and as I said, I mean, as you can see, the hybrid A, the standard deviation of the hybrid A is larger than the standard deviation of hybrid B, right? So, of course, conclusion here is that the hybrid A is more dispersed than the hybrid B, right? So, again, here, hybrid A.
And Professor, just 1 second. So
Yes.
when you're doing that, how you just did all of that formula for hybrid A, you have to do that formula all over to do B too, right?
Yeah, absolutely. Yeah, of course. Yep.
Okay.
Of course, but we have different numbers, right? So of course, yeah, they follow the same steps. So yeah, so the hybrid A is more dispersed than hybrid B. Okay. Has more variation than hybrid B. Let me just say one more thing, guys. I mean, we can also use the the standard deviation to find the exceptional values, right? Remember, we talked about this outliers. We said those are like exceptional values. Values are which are like different, very different than the others, right? So we can actually use this the standard deviation to find the outlier. So the idea is an outlier would be, or exceptional value would be, it's a value that which is more than 2.5 standard deviation from the mean. Yeah, so that yeah, so the idea here, so we can use actually it's standard deviation. Standard deviation to find exceptional values, to detect, let's say, exceptional values or outliers. Okay, and so the idea is that, so an outlier would be, is a value that so an exceptional value or an outlier is so would be a value that it's more, is a value, okay, which is more than, let's say, 2.5 times, oops, 2.5 times the standard deviation from the mean. Standard deviation from the mean. Okay. So, for example, let me give you an example here. I'm gonna use my example with. I'm gonna use my first example. What was my first example? So we have this example with, 17, 19, 20, and then 27, right? 27, okay? So this is the example I used to compute the first example I used to compute the standard deviation, right? And we said that the standard deviation was, what was the standard deviation of this example? I think it's 4 point, where is it? Yes, right here. It's 4.69, right? So it's 4. So it's standard deviation of this example. So S, standard deviation of this example, it's 4.69, right? Now, what's the mean of this example? The mean, X bar, the expected value. So of course, the mean is, sum of the numbers, 17 plus 19, plus 20, plus 27, plus 27, over, we have 5 numbers, so divide by 5, sorry. So the answer where is it? It's 110 over 5, right? And so the mean is 22. Okay. That's the mean. Now, so what I am saying here by my remark about the exceptional values. So if you have a value that's more than 2.5 times the standard deviation from the mean, then it's actually an exceptional value or an outlier. Okay. So like in this example, so what would be 2.5 times the standard deviation. So the distance here between the mean and an outlier is actually 2.5. Okay, that's like this, by convention, that's the number we use to detect the exceptional values, 2.5 times the standard deviation. So 2.5 times my standard deviation, it's 4.69, right? So times S. So 2.5 times 4.69.
11.
And that would be, excuse me?
11.72.
Thank you, 11.72. Thank you. I have so many numbers in my notes, as you know, I'm just, sometimes I'm just lost. Anyways, so that's supposed to be the distance between the mean and outlier, right? So now the mean is 22, right? So the mean is 22. So 22. So so if you have exceptional values, they're gonna be are higher than the mean plus this 11.72, or they're gonna be less than the mean minus this 11.72. Okay, so like in this case, the mean is 22, right? We said our mean, it's 22. So the 22 plus 11.72, that will be equal to 33.72, right? Again, the mean, it's 22. And then 22 minus 11.72, that will be actually, I think, 10.28. Okay. So the question is, do we have some data values higher than 32.72? Or do we have like data values less than 10.28? So as you can see, my data values, the smallest data value is 17, right? So we don't have a number which is less than 10.28, right? Because the smallest number is 17. And the largest number in my data values is 27, okay? And 27, it's not higher than 33.72, right? So like in this example, we don't really have any exceptional values. We don't have any outliers, okay? So let me just conclude with this, guys, in 10 seconds. I'm sorry, I went over time. The conclusion, and I will come back. I mean, anyways, I mean, we didn't finish this section, so I'll come back to this next time. So conclusion here, we don't have any exceptional values. In this example. Okay. All right, guys, I'm gonna stop here. Anyway, so as I said, the next time we need to finish this, so I'll come back to this remark in more details. And hopefully I'm gonna see you next Tuesday. Okay, so again, no classes on Monday, and we'll see you on next Tuesday. Take care, everyone, and thank you for listening.
Thank you,
Professor.
Professor. Have a nice one.
You
Go
too.
ahead. Go ahead. Okay, I want to know, you want me to stay on? You want to go over this work now, or you want me to wait?
Um,
Because I don't want to move on if I did it wrong.
oh yeah, sure. I can take a look. Yeah, sure.
You want me
Uh,
to stay on here or just wait till you get back to me?
I mean, you want me to send just
I'm
send you an
sorry,
email?
There's no homework, right? Or
No, there is a homework due tomorrow.
tomorrow? Okay,
Yes.
have a good
Mhm.
one.
You too. Kayla, let me first stop sharing the board.
I
Okay.
already got like 4 pieces of homework and I'm not
Okay.
even done yet.
All right. So, okay. Yeah.
I think my midpoints, I think they're right, because remember how you said it should be like 6, like whatever the sample size is.
Mhm.
So if the sample size was 6, then they should be
Mhm.
6 point, I don't know. You want me to tell you what I got?
So you sent me your answers, right? Okay. Give me just 1 second. I'm gonna just check. Try to find your email. All right.
I got everything in front of me too, just if you need me to tell you.
Oh, okay. Can you share? I mean, I guess you can probably share. Not the file, but
Do you want me to resend it?
no. I will find it.
So you want me to tell you my frequencies?
Um,
Because remember, I messed up the limits. Remember, I had to change, I had to fix my upper limits
yes.
from 2 down. So I have, starting from the first class for upper limits,
Mhm.
7, 13, 19, 25, 31, and 37.
Yes, that's
Oh,
correct.
thank God. All right, my
So
frequency,
what are your frequencies?
1,
Yes.
2,
Mm-hmm.
5,
Yep.
4.
5, 4. Yes.
Yes, thank God. 6
6. Yes.
and
Yes.
0.
And 0. Yep.
Amen. All right, so that's that. Now, you wanted me to tell you my cumulative, since the way you get the cumulatives is adding from the frequencies.
1 second. Sorry. I'm sorry. Just make sure last class. Okay, I just want to check your answer. So it's 1 + 2, 3, 5, 8, 12, 18. Let me just check one thing. I'm sorry.
Okay.
I'm gonna just try to
Oh, you see it now.
just see check something here in the homework. So make sure that we have 18. I'm trying to open the file. I'm sorry.
It's okay.
Okay, a couple of seconds. So let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. Yes. So your last class. What's the last class? Let me just check again. What's the limits of your last class? Or limits of
My last class, I have, for my 6th class, I have 32 and I have 37 for the upper limit.
No, wait. You're talking about the first exercise in the homework too, right?
Yeah, I'm on the first part, because you got to do the
Yeah.
class limits.
Mm-hmm. But then we have 5 classes, not 6. So I think you don't need the last one, right?
Okay.
We need 5.
Oh, well, I did 6. All right. So did that mess everything up?
No. Just you just don't need the last one. That's all. The other
Oh.
one are correct. I mean, your answers. That's why I want to check, because but your frequency. I mean, your limits of the first 5 classes. The limits are correct, and your frequencies are correct. But then you don't need the sixth class, okay? Because
All right, so that's good. Finally, I'm getting something done here, because it's like, Jesus, forgive me. So now, because I did the mode, remember when we were doing mode and median in the
Yeah.
mean?
yes.
How come those numbers are so long? Like I got like a 4, like 0.33333333.
Now, so you can just stop after. I mean, you can round your answer. So, for example, if you have like 4.3333, you can just write 4.34, or you can just write you can just take like two numbers after the decimal point. So,
So
you
I
can
could do
just take,
4.33.
yeah, 33. That will be fine.
So is my stuff right?
Yep.
It is?
Yep. You're talking your mode or your midpoint.
All of them. My
Uh,
mode is 5.
Okay, let me see again. Okay. Yes, you are talking about the number 2, right?
Yes.
5. Yes, that's correct.
And the
And-
other 2 are correct?
Yes, they are correct. Yeah.
Is number 3 correct?
1 second, because I don't have. I mean, I don't have the answer on top of my head, right? I have to check.
Oh, I'm sorry.
No problem. So what's your mode of the number 3?
For number 3, I got number 1,
Yes, that's correct.
and then I got 3, and then I got
Um,
3.26.
You're saying your median is 3. Median is 3.
Yeah, because for some reason on my paper, I had 2.5 over there.
Okay, let me just 1 second. I'm
And then I
gonna.
have 3 again.
So you have how many numbers? You have 1, 2, 3, 4, 5, 6, 7, 8. You have 15 numbers. So the middle would be the 8th number. So the 8th number. So we start 0, and then you have.
'Cause I know the data values was 18.
Um,
2, 4, 6, 8, 10, 12, 13, 14, yeah, 18.
Should be 3.5.
Oh, okay.
We have 15 numbers. We have 15 numbers. So the middle, the position of the center should be the 8th number. And now, if you order your numbers, the 8th
Oh,
number.
yeah, that's what I have. I have written down here, but I have median. I put 3 though.
Mm,
That's not right.
3, it's not your 8th number. 3 would be the 7th. I mean, if you order your numbers, like you
Mhm.
have 2 zeros. Sorry. I think probably you're right. So sorry. So we have 2 zeros, then 4 ones. So we have 6. Now 7. No, you're right. Sorry. You're right. Correct. Median is 3. Sorry.
It is?
Yes.
All right, and now on the homeworks, it says, I'm gonna do these. I just had a question though. When
Mhm.
it's asking highest frequency, it's just asking me for my frequency, not cumulative. Right? Because it
Mhm.
says which class has the highest frequency.
Yeah. Which class
So
has it?
that's my frequencies.
Yeah. So like.
Oh, no,
like-
you can keep going.
Yeah, so so I mean, according to your answer, the highest the class with the highest frequency would be the 5th class, right? Because it has 6 frequency, right? So that's, yeah, and the answer is the 5th class.
And then when I do my histogram, that's when I'm making the graph and I'm coloring it.
Yep.
And
the bars. Yep.
in my old jive, I get that from where I wrote that on one of my papers, where I know I get it from one of the frequencies.
Mhm.
No,
Cumulative frequencies. So,
it is, yeah, my old jive, I get that from the upper and lower limits,
boundaries.
the boundaries, I'm sorry, the class boundaries. That's how I make my old jive.
Yep. Use
So
the
I would
boundaries.
probably, like, for example, for my first class, I have 7.5 for the upper limit, and for the lower limit, I have 1.5. So it would be a 1.5 with the 7.5
Yep.
on my
Yep.
old jive, and I'm
Yep.
gonna section it like that.
Yep.
Okay, I'm taking note. All right, I'm gonna try to have this done and
Okay.
send it to you tomorrow. Maybe we can go over it and then I hand it in.
Okay. Sure. No problem.
All right, thank you, Professor.
I mean, again, you can email me. I mean, if you're stuck or you have questions, email me. I mean, I'll do my best to answer you as fast as possible. Okay.
All right, thank you so much. Have a great week.
You too. Thank
Yeah.
you. Thank you,
Bye-bye.
Kevin. Take care. Bye-bye.